All right, good morning and welcome back. Today we're going to start off with a little bit of review of what we've been doing so far. Okay, so we're going to start off over here practicing how to classify by sides. So hopefully you remember if there are three congruent sides, then we know that the triangle can be classified as equilateral. Okay. All right, so an equilateral triangle has three congruent sides. A isosceles triangle has two congruent sides. And then finally, if there are no congruent sides, we say that it is scalene. All right, now that's how we classify by side. We also can classify down here by angle. So if there are three acute angles, we would call that acute. However, the one time we won't do that, if all of them are acute but they are all the same, then we have three congruent angles. If that's the case, we want to use this one. Instead of equilateral, it's equiangular. Okay. And then if we have one right angle, we call it a right triangle. And if we have one obtuse angle, we call it an obtuse triangle. So that is the two different ways we can classify a triangle, either by angles or by sides. And as we look over here, I'm not going to do this all the way, but if we were actually, let's go ahead and just do it. If we were going to solve for x here, we need to start by filling in what do we know. So this blue dot right here, if I want to find that, hopefully you guys see these two blue dots are vertical angles, so those will be the same. So if we can find the one in the right triangle, we'll know what the left one is, and then we can solve for x. So if we focus just on this triangle to start with, we have 68 and 37, so we'll add those two together. And we'll get 105. Okay, so then from here, 180 minus that 105 will give us 75 degrees. Okay, that 75 is going to go right here. It's also going to go right here. Okay, so now from here, we can just add the 75 plus the 42. So 117, we'll take 180 minus that 117, and we'll get 63 degrees. That is what x is going to be equal to. All right, so now what we're going to do is we continue reviewing. Oops, once again, I need to fix that. So as we continue to review here, you'll notice here, triangle JKL is congruent to, we look at this triangle, by. So the first thing, let's fill in the by. Right here, we've got an angle, a side, and an angle, angle, side, angle. So our rule, angle, side, angle. And it's triangle JKL. So if we look here, we see that J is the same as Z because they both have two marks. So we know this one has to be triangle Z. We'll go first. Now the K has one angle mark, so that will mark with Y. So ZYX is what our answer will be. Okay. So now let's scroll down. And our next shape. On this shape, before we can identify Y, we need to add something else. FD here, by the reflexive property, I know it's the same whether it's part of the top or the bottom triangle. So now I have a side, an angle, and a side, or side, angle, side. So our reason will be SAS, and now it's triangle DFC, so DFC. Well, we know the D has to match up, so it'll, on the bottom one, it would be DFE. All right. Our next one here, Once again, let's add that reflexive property. It tells us US is the same whether it's part of the top or the bottom triangle. We have angle, side, angle. So our rule is angle, side, angle. And if we look here, R and U are the same. And then also the S side is the same. So if it's RUS, since R doesn't have a mark, we know that has to be T. It's going to be TUS. So triangle TUS. All right. Our next one. Once again, reflexive property tells us that this JK is the same whether it's part of the left or the right. So if we look here, HJK goes over the 1 and then the 3 mark. So we're going to have to go over 1 and then 3, so it's going to be LJK. So triangle LJK, and I forgot to write, our reason is SSS. There are 3 sides marked. Okay, now this one, be careful. If we look here, that's an angle, that's 2 sides. Okay, so remember angle, side, side. Uh-oh. Nope, we are not going to have that. If that's the case, angle, side, side, it does not prove it. The only time that does is if this was a right angle, we could use hypotenuse leg. But ASS is not going to be what we want, okay? Not enough information, so I'm just going to put NEI. Now, I know some of you might be tempted to say we can write a congruence statement, but we don't have enough information to know if any angles besides A and D are the same, so we are done. Oops. Here we go. Okay, so once again, we'd add that third side by reflexive property. And now it's going to be side, 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 triangle HEG. So HEG goes over 2 and then 3. So FGE would be over 2 and then 3. So triangle FGE. All right, right now we've got an angle and an angle. If this is a 90-degree angle, you guys see that's a linear pair. It's a line cut into 2 parts. If this side's 90, I also know then 180 minus 90, this side has to be 90. So now I have 2 angles that are parallel, that are congruent. And then TU here, I can put a mark because they're reflexive. So now we've got AAS for angle, angle, side. And triangle STU, well, we know that S matches with triangle V. T goes with T, so triangle VTU. All right, and let's do one more here. We'll wrap it up with this. So, and then we'll move on to proofs. But here's a side, here's an angle. We also can mark this side XZ because it's a reflexive property. It matches in both triangles. So we've got side, angle, side. That's our rule. And XWZ, in our case, it still has to start with X. But instead of W, it's going to go to Y and then Z. All right, so now that's kind of some review. We're going to take these same concepts of SSS, SAS, ASA, and SSS, and we're going to apply those to some proofs. So remember, hopefully you remember at least, the first thing we always are going to do is put our given. So in our case here, it says D is the midpoint. Oops, I got to change that to writing. Let me make this a little bigger. Okay. So it tells us that D is the midpoint. Of segment AB. I'm not sure what happened to those segments up here, but let me fix them. Okay. And then also we can add that AC is congruent to BC, and that is our given. Now, the AC is congruent to BC. That's already marked on here, so we're good. Now, if D is the midpoint of AB, hopefully you remember, if D is the midpoint of AB, that tells us that these two sides, AD, would be the same as DB, or BD, depending on how you want to say it. So AD, segment AD, we know is congruent to BD. And the reason we know this is because the definition of what a midpoint is. All right. Now at this point we have two sides marked. So we either need to prove another side or another angle is congruent, because 2 is not enough. Well, if you look here, DC, that is used in both triangles. So we can say DC is congruent to DC. And this one is our reflexive property. And if that is the case, now, as we were trying to prove, we can write this. So triangle ADC is congruent to triangle BDC, and our reason, we've got a side, a side, a side, 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 so SSS. All right, so let's take a look at the next one. Once again, we're always going to start off the same. Start with your given. So we got two things given to us. We know that segment CD bisects angle ACB. And then we also know that angle 3 is congruent to angle 4. And this is our given. Now, angle 3 is congruent to angle 4 is already marked on here, so those angles are congruent. If CD bisects ACB, a bisector, hopefully you remember ACB and CD bisects it, that means it cuts these two into two equal parts. So that tells me that I know angle 1 here is the same as angle 2. Now I put 2 marks because I don't know how they compare to these ones, but I know they are the same as each other. So angle 1 would be congruent to angle 2, and my reason, definition of a bisector. Now, this next step, 2 and 3, you could have had in either order. Some of you might have done it the opposite way. Hopefully you can look at this and see DC in the middle here. And DC is the same whether it's a part of the left triangle or the right triangle. It's the same length. So DC is congruent to DC. The reason is reflexive property. And now I have enough information on my thing. I have an angle, another angle, and a side. Angle, angle, side. So we can say that triangle ADC is congruent to triangle BDC. And our reason, angle, angle, side. All right. So a couple more proofs to look at. Once again, they give us some information here. So segment BC is congruent to segment DC. And this is already marked. BC here is congruent to DC. And we also know that segment AC is congruent to EC. And that is all been given to us. Now, it's easy to look at this and see two sides. Let's just put another mark on those. They do look the same, but we can't prove that. However, there is something we can prove right around here where I'm circling. Hopefully you know. Angle 1 and angle 2 are what we call vertical angles, which if they're vertical angles, that means they are congruent to each other. So since angle 1 and angle 2 are vertical angles, we can mark them as congruent. And from here, all we have to do then is write our final congruence statement. So triangle ABC is congruent to triangle EDC. And our reason is because if we look here, side, angle, side, side, angle, side. So SAS. All right. Got one more proof for you today. So this one proof I want to go over today, if we look here, it tells us, this one's maybe the most difficult. It tells us AB is parallel to CD. Okay, so segment AB is parallel to segment CD. And we also know then that segment AB is congruent to CD. So if AB and CD are parallel, then that means that AC here is what we'd call the transversal. And that would tell us, hopefully you remember from chapter 3, angle 1 and angle 2, what we call alternate interior angles. Now, alternate interior angles are going to be congruent. So I can say angle 1 is congruent to angle 2. Oops, I forgot. Right here I'm going to write given. And the AB congruent CD, that was already marked on there for us. Okay. So once again, these were what we called alternate interior angles. So because we know that they are congruent. Now the other thing we can see here, hopefully, AC, as we said, is a part of both triangles. Anytime you see a line that's part of both triangles, you know it is congruent to itself, whether it's part of the left triangle or the right triangle. It's the same length from A to C. If it's 5 centimeters for this first triangle, it's also 5 centimeters for the second triangle. If it was 10 centimeters, then it's 10 centimeters. It's going to be congruent. Okay, so I can write AC is congruent to AC, and this is my reflexive property. And so in conclusion then, I have a side, an angle, and a side. So by SAS, side angle side, I can conclude that triangle ADC is congruent to triangle CBA. Forgot the triangle sign, but yes. So ADC is congruent to CBA. All right, that's all I got for you today. Hope you guys have a great Thanksgiving break, and I'll talk to you later.